Hello students, in previous lecture we have studied about the surds, the simplest form of surd, comparison between surds, order of surds as well as operations takes place on the surds, that is addition of surd, subtraction of surds, multiplication of surd and division of surds, as well as like surds and unlike surds. Then the few more concepts which is related with the surds, we will discuss those concepts in the next few lectures about the surds. Then first of all we have to solve the examples from practice set 2.3. Then see here in question number 1, state the order of following given surds. Then see here few examples of surds are given here. Out of this, see here root 3 7, in which see here order, that means here in this surd n is equals to 3, that is n which is a positive integer. Here a is equals to 7, where a is radicand and n is degree of that surd. Therefore the degree of this surd is 3, that means degree of cube root of 7, that surd is 3. And the second one example which is given here, that is fourth root of 10, of which degree of this surd is 4. As well as one more example, that is square root of 39. Here we can't see the value of n. Then here n is equals to 2, that means it is a quadratic surd. Quadratic surd of which degree is 2. Degree of this surd is 2. Then see here the few examples which is given in the question number 2, in which we have to find out whether the following examples is of surd or not. That means state the surd of following examples. Then the few examples I am going to discuss with you, that is cube root of 51. See here, if the 51 is factorized into, see here, cube root of 17 into 3, then 17 and 3 both are prime numbers. Therefore the cube root of 17 or 3 cannot be takes place. Therefore here cube root of 51 is a example of, it is a example of surd, because the value of cube root of 51 is irrational number. It is an irrational number. Therefore cube root of 51 is an example of surd. Then one more example that is given here, that is fourth root of 16. Then first of all we have to factorize that 16, that is fourth root of 2 into 2 into 2 into 2, that is the factors of 16. 2 into 2 4, 4 into 2 8, 8 into 2 16. Then 2 into 2 into 2 into 2, it can be written like this, fourth root of 2 raised to 4. And see here nth root of a raised to n is a. Similarly fourth root of 2 raised to 4 is 2. That means here fourth root of 16, the value of that is 2. It is a rational number. 2 is a rational number. Therefore, fourth root of 16 is not a surd. It is not an example of surd. Similarly, we can find out, which is given in the question number 2, whether those are surds or not. Then we have to solve the examples from question number 3. In question number 3, here we have to classify the following given pairs of surd into dislike surds or like surds. We have to find out whether the given pair of surds are dislike surds or unlike surds or like surds. One of the example which is given here, that is root 52 and 5 root 13. Then we have to first convert those surds into the simplest of all. Then here root 52, see here, that is 4 into 13. That means 13 fours are 52. And here 5 root 13. 13 cannot be factorized because it is a prime number. And see here root 52, which can be written like root 4 into 13. Therefore, square root of 4 is 2, which is taken outside that sign, root sign, and therefore 2 root 13. And see here 5 root 13. See here in which the n is equals to 2 as well as a is equals to 13. That means here degree of both order are same as well as radicands of both surds are same. Therefore, here 2 root 13 and 5 root 13 are like surds. Like surds. That means 2 root 13 means root 52 and 5 root 13 are like surds. Then if we have to identify the given surds are like surds or unlike surds, then we have to first convert it into their simplest form. And if the order of both surds are same as well as radicands of both surds are same, then those are like surds. Otherwise, those are dislike or unlike surds. One more example which is given here, 5 root 22 and 7 root 33. Then see here 5 root 22, then 5 root 22, 11 into 2, factorization of 22, as well as 7 root here 33, which is factorized into 11 into 3. But 11 and 2 both are prime numbers, as well as 11 and 3 both are prime numbers. Therefore, we can't convert it into the, that is, more simplest form. Therefore, see here 5 root 22, here in which n is equals to 2 and here n is equals to 2. But here a is 22 and here a is 33. Therefore, here those 5 root 22 and 7 root 33 are unlike surds. Unlike surds. Then see here, for like surds, the degree of both surds should be same as well as radicands should be same. Then those surds are like surds. Then the next question, that is question number 4, in which few examples of surds are given in different form and we have to simplify those surds. Then the example from question number 4, one of the surd is given here, that is square root of 27. Then we have to convert this into p nth root of a, that is in the simplest form. To convert it into p nth root of a, then we have to factorize 27, that is, see here, 9 into 3. Therefore square root of 9 into square root of 3. Therefore square root of 9 is 3 root 3. That is the simplest form of root 27. That means root 27 means 3 root 3. In which, see here, 3, that is p is equals to 3, n is equals to 2 and a is equals to 3. Then one more example which is given here, that is root 250. Then we have to factorize it into root 25 into 10. That means here root 25, that is 5, root 10. 10 can be factorized into 5 into 2, but 5 and 2 both are prime numbers. Therefore 5 root 10, in which here p is equals to 5, n is equals to 2 and a is equals to 10. That is the simplest form of root 250 is 5 root 10. Then few more examples which is given in the question number 5. Then we have to compare between those surds which is given into question number 5. Compare the following surds. Then one of the example or pair of surd is given here, that is 5 root 5 and see here 7 root 2. Then when we compare between two different surds, then we have to convert those surd into its mixed form of surd. Then see here 5 means it is a root 25 into root 5. That is, see here 5 into root 5. Therefore 5 is converted into root 25 into 5. Therefore here root 25 into 5. Therefore here root 25 into 5, 125, root 125. Similarly 7 means root 49 into root 2. Therefore root 49 into 2. Therefore here root 98. Then see here order of these two is same, and here, but here 125 is greater than 98. Therefore here root 125 is greater than root 98. That is the comparison between those two surds. That means root 125 means 5 root 5 is greater than 7 root 2. That is the comparison between two different surds. Then one more example which is given in this question, that is 7 and 2 root 5. Then see here we have to convert both into this. See here 7 means root 49 and here 2 means root 4 into 5. Therefore here root 49 and root 4 into 5, that is root 20. Then here 49 is greater than 20. Therefore, root 49 is greater than root 20. Then we have to take one more precaution when comparison takes place between surds. That is, the order of both surds should be same. Then root 49 means here 7 is greater than root 20 means 2 root 5. That are the few examples, that is, of surds which we can compare between those surds and determine which one is the biggest surd and which one is the smallest surd. Then few more examples are given here in the question number 5 for comparison. Then you may solve those examples, remaining examples, in your textbook. Then in question number 6, the few examples which is given on the operations of surd, that is addition and subtraction of the surd. That is question number 6. Simplify the following examples. Here one of the example is given, 9 root 5 minus 4 root 5 plus root 125. Then see here, first upon, while addition or subtraction of surds takes place, then we have to convert those surds into like surds. Then see here, 9 root 5 minus 4 root 5, here those are the like surds. Therefore 9 minus 4 root in bracket root 5 plus then root 125, that should have to convert into its simplest form. Therefore 125 means 25 into 5. Therefore see here, 9 minus 4, that is 5 root 5 plus here root 25 means 5 root 5. Then both are like surds. Therefore see here, 5 plus 5 in bracket root 5 is taken common to it. We can do the addition or subtraction of those like monomials or polynomials. Then here 5 plus 5, that is 10 root 5. Then one more example I am going to discuss with you, that is, see here, root 7 minus 3 upon 5 root 7 and plus 2 root 7. Then see here, those all are like surds. Then here we can't see the value of p. Therefore when there is no any number here, then we have to write 1 into root 7. Then see here, in those all surds are like surds. Therefore we can do the subtraction as well as addition. Then see here, 1 minus 3 upon 5 root 7. We have to write that third surd as it is, plus 2 root 7. Then see here, 1 means here 1 upon 1. 1 means 1 upon 1 minus 3 upon 5. Then we have to solve this bracket. Then 1 into 5, that is 5 minus 3 into 1, 3 upon 5 into 1, 5. Then root 7 plus 2 root 7. Then see here, 5 minus 3, that is 2 upon 5 root 7 plus 2 root 7. Then see here, plus 2 root 7. Then both are also like surds. Therefore 2 upon 5 plus 2, and that 2 means 2 upon 1 taken in a bracket, and common root 7 is written here, and therefore see here 2 upon 5 plus 2 upon 1, that means 2 into 1 2 plus 5 into 2 10 upon 5 into 1 5 root 7. Therefore see here 2 plus 10 12 upon 5 root 7. That is the simplification of given those examples in question number 6. Then see here in question number 7, few more examples are given here. Question number 7, we have to simplify. First example which is given here, 3 root 12 into root 18. Then see here 3 root 12 into 18 is written like this. Then we have to factorize 12. See here 2 into 3, then 18, which is also factorized into 2 into 3 into 3. Then see here 3 root 2 into 2, that is 4, into 3 into 3, that is 9. Then remaining 2 into 3 is written like this. Then see here 3 root 4 into root 9 into root 2 into 3, that is 3 into 2 6. 2 and 3 are both are prime numbers. Therefore see here 3 into root 4, that is 2, into root 9, that is 3, into root 6. That means here 3 into 2 6. 6 into 3 18. 18 root 6. Then one more example which is given here, that is 5 root 8 into 2 root 8. Then see here 5 into 2 into root 8 into root 8. Then we have to write 5 into 2, that is 10, into root 8 into 8. Therefore 10 into root 88, that is 8 into 8 64. But 10 into root 64 is nothing but it is a 8. Therefore 10 into 8, that is 80. That are the few examples of multiplication of sets which is given in the question number 7. And there are few more examples are given in the question number 7 in the practice set 2.3. You should solve those examples in your textbook. Then in question number 8, the examples which is depends upon division of set. Then the question is given here, divide and write the answer in simplest form. Simplest form. Then example which is given here, that is root 98 divided by root 2. Then see here root 98 divided by root 2. It should be written like this. Therefore see here root 98 divided by 2. Therefore see here we have to simplify. Root 98 divided by 2, that is 2 1s are, 2 4s are 8, 2 9s are, therefore root 49. Therefore root 49 is 7. That is the answer, which is in the simplest form. As well as one more example which is given here, that is root 54 divided by root 27. Therefore the same example which is written in the form of root 54 upon 27. Then all of you have known about that 27 2s are 54. Therefore square root of 2. And square root of 2 is a simplest form, which is in the p-nth root of a form, in which here p, which is 1. Therefore here p is 1, n is equals to 2 and a is equals to 2. That means here root 2 is the simplest form of that surd. Then that is about examples which is given in the practice set 2.3. Then few more concepts which is related with the surd. That is one more concept which is related with the surd, that is rationalization of the denominator of the surd. Then examples which is based on those concepts which we will solve in the next lecture. Solve the examples from practice set 2.3. Thank you.